Welcome to part 2 of session 1 of week 6. In the first part, we looked at the details of how loggers work with a small example called log test. Now we are going to see logs in use in our application. What we have learned last time is that the log4j system provides a logger, a log configurator, and log appenders. We have seen some examples of this in the code for log test. So let's just refresh our memory a little bit. There is a log manager here. Then you start making these calls, info, debug, trace, etc., which write these messages with a little tagline, which is then useful to separate out different parts of the system and to duplicate it onto the console and the file and so on and so forth. We also saw that in the config file here we had log test, and we have the logs going to the console and to the test app log, and the test app log that we see is in here. We decided to put it in logs and called it fairshare.log. Right now there is nothing in it. So the place where the file name should be created was given here, and accordingly the log file got created. Okay. Now we also saw the overall arrangement of the classes in the logger, and we saw that you get these types of lines with info, warn, error, fatal, etc. The exact shape of the message is decided by this pattern layout. It has a somewhat cryptic structure, but it is well explained in the log4j documentation. So let's just briefly go over it. This is obvious. This is the date part. This is the level. And this is which logger are we talking about and what the message is. Now here we see this. So here we have this tag, here we have the date, the level, the name of the logger, and the actual message, the kind that we see here. Okay. And this is the same file that we are seeing over there on the left. And now we are going to take a look at application logging. So to understand how application functions, we have already seen how we use the browser tools and the logger. But beyond this, there are things we can do. For example, let's take a look at this thing. Here we have our familiar form. Let's do our standard application. Expense F1 200, report F2, and end. And now when I submit the form, I get this. But if you look at the actual HTML for this by doing Ctrl U, you will find that at the top, hidden as a HTML comment, is this kind of debug information. This tells us that the first command was analyzed, then it did registration, then it looked at the second command, looked at the third command, and finally the whole thing ended. How was this done? Let's take a look at the code for this thing. So we have fairshare html interactive.java, and here, for example, is where the code begins. So in the function called doSetup, we have this line which prints out the comment part of the HTML, which is this tag here. This is a HTML comment, and then throughout the body of the system we have lines like this. For example, system out print line, info prefix, etc. Now info prefix is defined up above, prefix there. So we have an error prefix and we have an info prefix. This serves the same purpose as the lines we have seen in the log file, namely these types of lines over here, which we also saw show up in the tests that we have done. Let's see, do we have log test logs here? Yes, we do. So here we have info, warn, fatal, etc. And these kinds of tags can also, of course, be hand created by doing info prefix like this. So if you keep going down, if you search for a print line, you will see that you have command is, you have this mode, and then there is some error analysis, and within each of these things, so this is the actual HTML output, but even before HTML output, if we look for say these kinds of things, do registration, for instance, do registration, we find this kind of material which is doing the output, and from time to time we also have the code that outputs this kind of thing. So let's say done calling do registration. Let's search for the word done. So this is what we have done. Do registration, system out print line info prefix and error prefix after catching the exception if something went wrong in the do registration, and announce that you are doing the calling. So this can be done, of course, but we would like to do it using logs, and we will see some of the advantages of doing these kinds of things using logs. But this is a simple way of adding sort of directly useful type of information in the web page itself. And once we have begun printing these types of comments, we have to make sure that at the other end we also close the comment, so that when you look at the page, the actual original page, the comments don't show up anywhere, and here although the debug information is present, it does not interfere with what the user sees, which is good for us to understand what is going on, at the same time as having the exact same output that the user sees. Okay, now let's take a look at the other version. We have FairShare 3, and in this we are going to do a few different things. So first of all, in FairShare 3, we are going to have this information here, log level, which is going to allow us to change the logging level that is visible. And we have also made some changes to the FairShare HTML Interactive 3 by using log lines. So for example, instead of having system out print line, here we could have something like logger trace, but this has a problem. The issue is that the logger is designed to work on a per message basis, and these loggers at least do not have a sense of begin and end, and we would have to deal with this on a message by message basis. So we are going to do something different. We'll look at the results in a minute, but here is the change we made. So where the earlier system might have said something like, let's see, so here we have system out print line followed by, in this case, system out print line info prefix something. We have logger.info command is. Now it's saying the same thing as this, but saying it in a way that gives us a manifold set of advantages, as we will see in a while. So here we have logger info, mode equals something. Here we have system out print line info prefix, and again mode, and so on and so forth. So throughout this file we have gone, and wherever the information intended for debugging was included, we have replaced this with logger. So here we have this part, but the output itself So system out println is still used for the output itself. So this kind of thing, the actual HTML content is still collected in a string and printed out as output messages in this case. This part we have left as it is, and the rest of the what is sometimes called meta information we have moved to the logger. Let us see what happens when we do this sort of logging. So let's submit the form. Let's start this thing here, submit the form, and this time the result is quite different. Message by message, every single interesting message appears as a comment, and here we have the log level, here we have the message as it is printed, and here is the time in milliseconds. So this helps us understand how much time was spent in each of the stages. As you can see, trace messages are visible here as well as info messages. And this was achieved by these kinds of things. So logger.info versus logger.trace. So logger.trace. So we have two kinds of messages. Trace, as we said, is detailed debugging, and info is normal debugging. So for example, there's no reason to distinguish normally between beginning the call versus being inside the call and doing the actual work. But as an example, this is what we have done over here. One interesting thing is that we can control, as we said, fair shares logging without touching the Java program. So for example, here, if I change the log level to info, save this file, go back here and submit the form again, and now I open up this new thing. As you can see, there are no trace calls in here as there are over here. So without changing the actual Java program, we were able to change the output that we see in the place where we want debugging. But that's not all. We can also show that the log output has gone to the other place where we care about, which is tail-f logs fair share.log. Here we have this output. Just to confirm, let us do this all over again. We will go back and I will bring this over here. Let's submit. And as you can see, this logs also appeared over here. And on this side, again, we have this info only. Let's go back and change this to trace. So we'll change that to trace. Go back here. And now watch for the difference between these two. So we submitted the form, but notice that there are no trace statements here, whereas there are trace statements in this debugging. So the logger infrastructure allowed us to do a bunch of things. It allowed us to send this information in two places. It allowed us to take this message and format it quite differently, once for the web page and once for the log file. The message remained the same, but the decoration around the message was changed. It also allowed us to have two different levels, so that in one place where we want detail, it is available, but in the other place it is not. And there is more that can happen. So let's do one more change and then we will see something else. So this time I'm going to inject an error by putting a command which the system does not know. Now let us see what happens. So here the system decided to ignore the command and continue to make sense of what it could. But to warn us, it printed this message. It said error fair share. And error shows up here and of course also here. So error is considered important enough that it is more important than trace and more important than info. And so it will show up in both places. Just to verify, suppose we change the log level to warn, which is a higher level than info. Then we go back, we maintain our error over here, and let's clear up things and submit the form. This time, the only message that we see is the error message, and same thing here. The only thing that shows up is the error message, and the rest of the processing happens as normal. So we were able to make all these changes without changing the code. Let's see logger.error. So this is the unknown mode message that we see, and there is, I think, one other place where we should make this change so we can check this error prefix thing, and ideally this should also be the logger dot error. No need for error prefix now, this record. But this time of course we'll have to recompile the thing, which is fine, no big deal. We can recompile it. This catches another error for which we don't have a model yet, but it's good that we can find this and change it to a standard style. Let's go back and change warn to trace again. Save this. Go back here. Submit. Okay, we are getting error over here. This is coming up, and so we are back to the configuration we had started with. Now let's see how this is done. So all this is done entirely in the log4j config file, and this is the idea. So this is our logger for fair share, and it contains two things. It has an appender called web page, which works at the level of trace, and it has another appender called fair share log, which works at the level of info. The fair share log appender is this one. It is a file which is logs.fairsharelog, and its pattern looks like this. Whereas the appender web page is in fact a console appender, because we know that for CGI all we have to do is put out this information on the standard output, and it automatically goes to the web page. But this time compare this pattern with the pattern for the log here. This thing and LT semicolon is an HTML escape sequence which generates the less than character. Similarly, GT generates the greater than character. These two are responsible for this tag and this tag over here. Let's arrange it so that we can see both things at the same time. So we have this LT tag and we have --GT, which is what we have here. So this thing does one level of interpretation, and therefore the less than and greater than have to be encoded in this time. Then we have left justified. So this is a level tag with 6 characters, left justified. So we have info and trace arranged like this, and then the message. So the message is left justified in a 40 character field so that we get these things nicely aligned. And then we have milliseconds, Unix style, that we add here. And so we keep the message the same, but get the result in two different places with two different levels and two different formats. And so both of these requirements of getting the log to the user directly, well, to the developer directly into the web page, as well as information in the log, is achieved. Now let us see how we were able to change the log level without changing the Java program. And here the idea is pretty straightforward. We have environment variable that we have set in this shell script, which drives the Java program. And then the Java program, what it does is this thing. I will have a set log level. So I created a function called set log level, which does the following. It sets up a hash map which contains these strings and maps them to the corresponding level. This thing is needed because the Apache logger acts by using the enum called level rather than strings, so we make it happy. And this is somewhat unfortunate because this unnecessary enum means that we need these kinds of conversions. But in any case, we have this map. So what we now do is we first set the level to be info by default. We check if the environment has a variable called log level, and if the variable exists and it is not null, then we actually get the level that it wants and set the configurator to this level. This is, by the way, the same as what we were doing for log test, where we set configurator log level directly by way of showing you how to make the change dynamically. And here we get this level from elsewhere and then set the configurator. By the way, this is not the best way that you could use to set up the log level, because we actually had to go and change this file to make the change. A much nicer way is to either provide a query term in the URL or use a cookie, or you can also check which IP address the system is coming from, and if the IP address belongs to the development organization, then you can directly include the debug information every single time. All these three things are possible, and we will see some of them later on. But for now, for this simple program, I just use this method, which not only creates a new variable and a new file called fairshare3 plus a fairshare3 interactive that uses the log to show what can be done. And the reason I did not use a query string or a cookie is that we haven't done that yet and we don't know how to do it. Plus, setting it using the query string means that some amount of parsing is needed, which for a shell script and the CGI setup that we are using, it is a little troublesome. So when we go over to servlets and have some of these kinds of parsers, etc., directly available, then we will start using these more sophisticated methods. So at this point, this is what we have seen. We have seen that there are loggers. There are two different loggers that are available, and one of them can be directed to the web page, whereas the other to a file. We have also seen that in CGI, console goes to web page, so we can say that writing to the web page is the same as writing to the console, and we can change the meaning of these appenders to get the effect we want, plus we can get the message format we want as well. All right. Here is what we have done. We saw that fairshare2 had hidden debug info. It was generated with system.println. We changed it over to using logger, and we made the connection between the web page and the logging explicit in the logger config. Alright, now let's take a look at one more use of this kind of logging level, etc. Let's see how we can use curl to interact with the application. And what we will do this time is we will take these two command sets and okay, so first of all we are going to use curl. Curl has an option called -d where you can provide data like this, and this time with -d curl does a post call. It automatically gives the content type application xww form uncoded. It asks for data and determine the other headers yourself. And how did we get the data? That is of course our standard approach, which is go to this post, use edit and resend, and copy this request body. Everything else like this thing, content type application xww form encoded, is taken care of by curl. So let's go here and let's see what happens. We get the result and we get the log. The nice thing about this is because these are command line applications which give you the results, it is very easy to write automated tests that do this kind of a job. And as time goes by, as you will see, we have accumulated quite a bit of the log here. Let's go here and do this. And as you can see, already fair share log is actually that big. And if you look at how many lines have accumulated, we have around 112 lines of content in the fair share log, most of which is essentially these same chunks of info. But naturally, if we wanted to, you could also let's try again, tail-f fair share dot log, and here we have curl, and we can add, instead of report, let's change this to something else, report x. There will be an error there, and we can send this, and now we have an error. Plus, this information may or may not be correct at this point because the report was not properly specified. But which is okay, we expected that. We intentionally injected an error. And the rest of the posting part, curl took care of on its own. If you want to see what curl does, you can add the usual sort of verify. So let's remove this error and add -v. Okay, so here we see the headers and here we have the interaction. As you can see, curl made up all the correct headers. It said it's post, host, user agent, etc., etc., content length, application, xww form, URL encoded. And these are the usual sort of received headers. Good. So there we go. Besides curl, there are other libraries. There are Python libraries, there are Java libraries, which allow you to automate this kind of browser interaction. But for simple things, curls and logs does the job pretty well. Incidentally, in addition to -d, there is a different sort of form that curl is capable of sending using an encoding called multipart encoding. And at that point, however, parsing starts becoming complicated, and working around with CGI scripts, we kind of come to the end of the things you can do with CGI scripts, and now you have to go to more infrastructure which caters to all these kinds of complexities. That is usually servlets, but technically speaking, if any Java library which deals with the input properly could be used. So we will, when we go over to servlets, we will discuss exactly what is limiting about CGI bin. But CGI bin is one of the more remarkable successes of the web, because it lets people write simple programs and get useful websites with very little effort. In general, logging is a very important part of web infrastructure, and besides the appenders that we have seen, there are others that go to sockets and databases. There are still other interesting ones. For example, there is something called a rolling file appender. A rolling file appender, which you could configure here in this config file, log4j2.xml. So instead of a file, you could have a rolling file appender, and a rolling file appender will actually once a day or some other specified criteria such as size or time, it will copy an existing file and start a fresh log file for the next day. It is common to have months and a month's worth of log files sitting around, often gzipped to save space, but it is necessary to go back and look at the history of what was happening in an application many times in order to figure out what is going wrong now. On very large distributed systems, people have written log collectors, they have written log search engines, there are failure pattern detectors, there are cross-service log correlation. By cross-service, I mean across multiple applications. And there are many packages available. For example, large websites use things like Nagios, Logalize, Greylog, and I'm sure more of these will be coming as people write them for one reason or another. Of course, we are just writing a basic web app, and for us, grep is sufficient. But it's useful to know that logging is an important part of web application development. We got involved ourselves in logging very early on, so that you get into the habit of testing using logs, which will serve us very well when we get to the more complex parts of our application. Okay, this is the end of part 2, and see you next time. Thanks.